All right, college algebra, we're looking at quadratic functions and models. Okay. On quadratics, that's when we have a parabola. It can open up or it could open down. If it opens up, we have the vertex down here. This is called the vertex, and it's the lowest point of the whole graph. If it opens down, the vertex is way up here, and it's the highest point of the whole graph. All right, so that's a couple questions we have first off in here. Well, first thing we have is if you have a polynomial with the leading term 9x squared, all right, x squared, this is your degree, so it has a degree of 2. We're looking at polynomials in this chapter, and quadratic equations are polynomials. So that's something we'll talk more about later, polynomial. Number 2 here, all right, this is what we're just talking about. The lowest point of the graph of a parabola that opens up is the vertex. If the lowest point is the vertex when it opens up. When it opens down, the highest point, and that's what this one is, the highest point on the graph that opens down is the vertex. Okay, number 4. I actually did this earlier, but the graph of this equation here, you can't really see it. It's negative 8x squared minus 4x plus 8. Okay, it opens down with a y-intercept of what? All right, now y-intercept is when x is 0. So if I put 0 in for this, well, negative 8 times 0 squared would be 0. So that'd go away. Negative 4 times 0 would be 0. So 0 plus 8 would be 8. So this would be the y-intercept. Okay, now if you have a y-intercept and your y-intercept value is positive and it opens down, all right, so here you go. So here's my y-intercept, 0, 8. And it opens down. That means I have 2 x-intercepts. Okay. Now, if it's 0, negative 8, and it opens down, okay, if this is negative and it opens down, you can't really tell how many it has, because it could open down and be like this, or it could open down and it be like that. So you're not really sure how many x-intercepts you have there, so you can't tell here. But if your y-intercept is positive and it opens down, then you have 2, so this would be 2 x-intercepts. Now, it's possible to have 2, none, and it's possible to have 1. You could have just 1 x-intercept, which may look like this right here, where it just touches at the vertex. Okay, so that's your possibility on the vertex. All right, now number 5 here. Match the following equation with the description of the parabola that it's graphing. Okay, now this is called vertex form. We've got x plus or minus a number in parentheses and it's squared, and then we have a plus or minus number out here. Okay, sometimes we could have a negative out front or a multiplier. Okay, but the main thing to know is when it's in vertex form like this, you should be able to determine the vertex. So here's my vertex for this equation right here. So right there where it says x plus 6, this is sort of like the circles. That means my x is negative 6. And then right there is my y, 4. This is my vertex, which means it goes to the left 6 and it goes up 4. Okay. So negative 6, 4 could be this one or this one. All right, so it has this vertex. Now, does it open up or does it open down? Okay, now in front of the parentheses on the x squared term, if it's positive, it opens up. If it's negative, it opens down. This is positive, so this is going to open up. So here's the answer here, G. You see G's the answer. Okay, let's look at this one here to maybe make more sense of this. All right, now see the negative out front? That tells us this is going to open down. Okay, so it's going to open down. And then my vertex, all right, here you go. It's x plus 9, so that means my vertex will be negative 9. And then here's my y right there, 7. So here's my vertex. So I'm looking for negative 9, 7, open down, is right there, A, first one. Okay. All right, number 7. For the given equation and graph of the function, do the following. All right, so here's this one here. You see it. This is going to be 3, negative 4. There's my vertex. You don't have to do that for this problem, but we're going to look here. See here, 3, negative 4. Right there's my vertex. Okay. Now, what's the domain of this? What's the furthest to the left it goes? What's the furthest to the right that it goes? Well, as this thing goes up and up and up, it's going over and over and over. So it goes over forever. Same thing on this side. As it goes up and up and up and up, it goes over forever. So my domain would be negative infinity to positive infinity. Okay? All right. Every quadratic is going to have that domain. Whether your parabola is going up or if your parabola is going down, it's going to go over forever to the left, over forever to the right. So my domain will always be this on every quadratic. Now the range is what's different. If you look at this one here, what's the furthest down it goes? Right here, negative 4. See there? It goes negative 4. And it does include it. So we'll have a bracket there, which will always have a bracket for the value of, as lowest value if it's going up. What's the furthest up it goes? It goes up forever, so this will be infinity. So you'll always have on your range a number and infinity if it's going up like this, or you'll have negative infinity and a number if it's going down. Now what's the vertex here? We already did that one. That's 3, negative 4. And then what's the equation of the axis of symmetry? Now this axis of symmetry thing, what that is in your parabola, you have an axis that goes right down through the center of it that would look like this right here. This is the axis, which is right down the middle, and each point on the left has a corresponding point over here on the right, which is symmetric. See right here, if you go to 1 for, if you go 1 high here, we've got a point over here to the left, we got one over to the right. Okay. So that's called the axis of symmetry. This is located when x is 3. See here? So this is x equals 3. Now find the y-intercepts. All right. We will only have one y-intercept no matter what. And on this one, if you look at it, it looks like it's right there at 5. So 0, 5 is my y-intercept. And then it says find the x-intercepts. All right, the x-intercepts right here and here are my x-intercepts when it crosses the x-axis. This looks like 1, 0, and this looks like 5, 0. So 1, 0, 5, 0. And you'll have to type it in like that. Okay. All right. All right, now this is number 8. So we see our equation here, our function, and here's the graph. Give the domain and range. All right, every one of these is negative infinity, positive infinity, as I said a while ago. The range, all right, now this one's going concave down. So the lowest value it goes is negative infinity. The highest value, it looks like right there, 2. Right there, 2. And it does include it, so you'll always have a bracket like that. All right, now give the coordinates of the vertex. All right, right here's my x value. So see, it's going to be a positive 6. It's always the opposite of that. And there's my y value too. So there's my vertex. This is in vertex form. Now, just real quick, see this -2? This means it's going down, and this means it's stretching. So you can see that on here on the graph. It's stretching it some. Usually this parabola would be more like this, maybe. So you can see it's stretching it. All right, now the axis of symmetry goes right down the center of this, and it looks like it's at 6. You see that? And then what's the y-intercept? All right, now this one here, we can't really tell on the graph. It's going to be way down here somewhere. See that? It's going to be way down there. So this one we're going to have to calculate the y-intercept by putting 0 in for x. So if I put 0 in for x, I'm just going to punch this in. You could just type this in the calculator or just do it in your head, whatever. But if I put 0 in for x here, that's going to give me -70. So that'd be 0, -70. Okay. And then find the x-intercepts. All right, we can look at the graph for the x-intercepts. And it looks like right there, which is 5, 0, and then right there 7, 0. So this would be 5, 0, comma, 7, 0. Okay, and I think we got all the answers right. All right, here's my answers right there. I think we got them all. All right, number 9, another one. Okay. This one we've got to graph ourselves. So I'm going to go to the screen. Okay. All right, so on this one, here's the function right here, x minus 4 squared. What's the vertex? All right, so we got this -4. There's my x, so it's going to be +4. And look, there's no number to the side here, which means that's 0. Okay. So I'm going to do my parentheses here. So it's going to be +4, comma, 0. All right, let's see what we got there. All right, good deal. All right, now we're going to graph it. Now, so we click on the graph. Now this is not going to have the boxes like parabolas we've done before. We're going to select parabola, and then we're going to place this where the vertex is. So I'm just going to go to 4, 0, and right there it is. So I click it. All right. Now, I look at this number in front of the parentheses, or in front of the x squared term. There is no number, which means it does not stretch, which means when I go over 1, it will go up 1. And there's my parabola. Now, if it stretches, if there's a stretch number, when I go over 1, I'll go up whatever that stretch number is. So like, if, for instance, if this had a 3 in front of the parentheses, it would be stretching by 3, which means when I go over 1, this would go up 3. So you see the difference, how it's stretched. You see that? But that's not what it is. It's supposed to be right there. So there's my answer. Okay. Now, what's the axis here? Well, it's at 4. Actually, your axis is always going to be the x value of the vertex. So this should be x equals 4. Okay. And then the domain, all right, every one of these is going to be -infinity to +infinity. Every one of the quadratics. Now, what's the range? All right, now the range is what's different on them. So the lowest value looks like it's 0 right here, 0, and it goes up forever. So 0 to infinity. Okay. Uh-oh. I didn't put a bracket on there. I was going too quick. This should be a bracket because it does include 0, so I put a bracket there. Okay. And then the largest open interval on which the function is increasing. All right, increasing, as you remember, if when you go to the right, it goes up. And that happens right here. This part right here is increasing. It starts right there at 4, and it goes to infinity. So from 4 to infinity, it's increasing. 4 to infinity. Okay. And then it's decreasing, right? This is decreasing right here because as you go from left to right, it's going downhill. All right, and it ends at 4. It starts at negative infinity, so this would be negative infinity to 4. So negative infinity to 4. All right, there you go. So the question is complete. That's number 9, then number 10. Okay, so here's another one. You see my function right here. All right, now my vertex. All right, there you go. There's my x value. So it's going to be negative 5 and then negative 4. All right. So I got negative 5, comma, negative 4. Uh-oh. Wasn't paying attention. I guess I accidentally hit... I like to do my parentheses first and then put the values in there. There you go. All right, now graph it. Okay, so I'm going to select the parabola, and I have to physically graph the vertex on this one. So that's going to be negative 5, negative 4, which would be right there. Okay, and then I have to go over and up. It's going to make my parabola, okay? But I look in front of the parentheses, in front of the x squared term, and there's no number, which means it has no stretch, which means when I go over 1, I'll go up 1. There you go. All right, fantastic. And then we're going to do the axis symmetry. It's always located at the x value, so I can just look right here, negative 5, or if you look at the graph here, negative 5 is right down the center of it. X equals that. Okay, now the domain, every one of them, negative infinity to positive infinity. Okay, every one of these quadratics are going to be negative infinity, positive infinity on domain. Now the range, that's what changes on this one. The lowest value right here is negative 4. All right, so now it's got a bracket now. I forgot to do that a while ago. And it goes up forever to infinity, so that'd be infinity there. Okay. Now the largest open interval on which the function is increasing, right here is increasing right there, which starts right here at negative 5, and it goes to infinity. So negative 5 to infinity. Okay, and then the largest open interval, which the function is decreasing, and that'd be this one right here. This is decreasing. It starts at negative infinity way over here, and it goes all the way to negative 5. So negative infinity, negative 5. Okay, and there you go. Question is complete. All right, 11. Okay, now we've got one like this. And this is not in vertex form. And this one here is already graphed. So we're going to go back to the paper on this. So this is number 11. So let me go back. And there's number 10. Here's number 11. All right. Oh, no, I'm sorry. I do have to graph this one. I'm just getting confused. But I am going to do it on the paper, though, because it's got this right here. This is not vertex form. Okay? When it's written out like this, I have to figure out what the axis of symmetry. So here's the axis of symmetry. This is how you find the axis of symmetry. X equals negative b divided by 2a. All right? This is the axis of symmetry. So what I do here is, on this one, x equals negative b. My b is negative 8. Divided by 2 times a, and my a right there in front of the x squared is 1. Remember now, this is 1. This is negative 8. That's 20. That's a, b, and c. We did this for quadratic formula, if you remember. So now this is going to be a positive 8 on top, and 2 times 1 will be a 2 on the bottom, which if you divide that, that equals 4. Okay? All right, so that's my axis of symmetry. My axis of symmetry is 4, which if you remember now, like we said a while ago, the x value is always the axis symmetry value. All right, so now what I have to do is figure out the y value. So I just take 4 and I put it in the function. So I'm going to type this in, 4 squared minus 8 times 4 plus 20. I'm just going to type that in on the calculator. So let me get my calculator here. All right. So I'm just going to type 4 in for x. I'm going to have, in parentheses, 4 squared minus 8 times 4 plus 20. And I'm getting 4. All right, so my y is 4. So the answer is 4, 4. That's the vertex. All right, so again, I do this negative b over 2a to figure out this is the axis of symmetry, which is my x value of the vertex. And then to figure out the y value, I just put the x value in, and that gives me the y value. So there's my vertex right there. All right, so now I graph it. Okay, so now when I graph it, I'm just going to do it on the paper here instead of on the screen. I go to 4, 4, which is right here. There's my vertex. Okay, and then if I look in front of the x squared, my a is a 1, which means there's no stretch. So when I go over 1, I go up 1. And so it's going to make this parabola. It looks like this. Oops. But anyway, that's what it will do on the screen for you. The axis we just talked about, that's x equals 4. The domain, every one of these is negative infinity to positive infinity, every one. The range, all right, now you can look at your graph. The lowest value looks like it's right here at 4. And it does include it. The highest value, well, it goes to infinity. And then the rest of these are just the same as the ones we've done. The large slope interval on which it's increasing, it starts right here at 4 and it goes to infinity, increasing right there. So it'd be 4 to infinity. And then the large slope interval which the function is decreasing. Decreasing would be this right here. As you go from left to right, it's going downhill. So this would start at negative infinity and go all the way up to 4. So negative infinity to 4. Okay. All right. All right, so number 12, it's another one that's, this is standard form. It's not vertex form. So we're going to have to do the same thing here. So I'm going to have to do the negative b over 2a. Remember now, the axis of symmetry. You need to know this one. X equals negative b over 2a. This is your axis of symmetry. And we're going to have to do that here, again, because it's not vertex form. Okay? So, we're going to do negative b over 2a. My b is negative 18. My a is 1. So this is going to be a positive 18 over 2 times 1 is 2, which is a 9. So my x value is 9. Now right here, the axis, x equals 9. Okay, I'll go ahead and write that in there. Now, I take 9 and I put it in the function. All right, so let's get my calculator again. I'm just going to put 9 in for x here, okay? So I'm going to do 9 in parentheses squared minus 18, and then 9 in parentheses plus 77, which is -4. So my y value is -4, and that's my vertex. And now we want to graph it. So I'm going to go to 9, and then -4, which is right here. Oops. There's 9, -4. And then there's no a number here. It's 1. A is 1, which means there's no stretch. So when I go over 1, I go up 1. And then once I do that one, just those 2 points, it'll graph it for me. So that's the graph. The domain, every one of them is negative infinity, positive infinity. The range, the lowest value is -4. It does include it. The highest value is infinity. And then same thing on there. The large sloping interval, which the function is increasing. Well, this is increasing, and it starts right there at 9, and it goes to infinity. And then the large sloping interval, which is decreasing. Well, here's the decreasing right here on this side, and it goes from negative infinity all the way up to that 9. Okay, and we're good to go there. All right, now, number 13. A is less than 0, and this b squared minus 4ac is greater than 0. Okay, now let me tell you a couple things about this. When you have your parabola, it opens up right here. All right, that means a is positive, so a is greater than 0. But if it opens down, that means your a is negative, so it means a is less than 0. See, when you have your function with your x squared term, if it's got a negative in front of your x squared term, that's going to send it down like this, which means your a term, see, this is your a term, this is your b term, this is your c term. But my a term right here is negative, which means a is less than 0. So your a term tells you if it goes up or down. Okay, so you should be able to look at one and know if it goes up or down. Now, if you remember this right here in the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now, I don't think we really talked about this, but this b squared minus 4ac, all right, this is called the discriminant. This right here, b squared minus 4ac, is called the discriminant. All right, this tells you about your solutions. If this b squared minus 4ac is 0, if this equals 0, okay, let me see here. All right, so if your discriminant is 0, then that means right here you got -b plus or minus the square root of 0, which is 0. So basically I have -b plus 0, -b minus 0, which are the same thing. Which that means this only has one solution, or one x-intercept. Okay? Now, if this thing right here is negative, then you got the square root of a negative, which is imaginary, which means you have no solution. So if it's negative, then that means you have 0 solutions. Okay, which means you have a parabola that's doing something like this. Okay, it's not, or it's up here like this. Either way, it has no solutions. It does not cross the x-axis. But if this b squared minus 4ac is positive, that means you have 2 solutions. Because you have -b plus that number, and you got -b minus that number, which gives you 2 different values, like we've done a quadratic formula several times. So that means you have a parabola that's going to cross like this right here, and it has two solutions. Okay. All right, well, let me show you this number 13 and 14. These can be a little confusing. I'm going to try to go through it real simply and straightforward. But if A is less than 0, A is less than 0, well, that means A is negative. Okay? So if A is negative, it means it's concave down. So we're looking at these two right here. These are concave up, so it can't be those. So A is less than 0 tells me it's A or C is the answer. Now right here, if my discriminant is greater than 0, which means it's positive. All right, so if your discriminant is positive, that means you have two solutions, which means it has to be this answer, because see here, there's two solutions here. This one doesn't have any. This one right here would be as if the discriminant b squared minus 4ac was less than 0, then that would be my answer. But anyway, my answer is A right here. Okay. All right, there's a couple more of these. Number 14. All right, A is greater than 0. Okay, A is greater than 0, which means it's going up. My A term is positive, so it's going up. So it's got to be this one or this one. It can't be this. Okay, so your A, if it's positive, A is greater than 0, it's going up, concave up. If A is less than 0, it goes down. Now right here, b squared minus 4ac is greater than 0, which means it's positive. So my discriminant is positive. That means I have two solutions, which would be right here, 1, 2. So this is my answer, D, not this one. Okay, there's one more like that. All right, 15 here. A is less than 0, which means it's going down. So it's got to be, this can't be those two. And then my discriminant is less than 0. All right, now my discriminant this time is less than 0, which means it's negative. If my discriminant's negative, that's imaginary, and I have no solutions. So this would be A. That has no solutions. This one has two solutions. This would be if the discriminant was greater than 0. But this is my answer right here. Okay. All right, now let's go to 16 here. An object is projected upward from ground level with initial velocity of 32 feet per second. Then its height in feet after t seconds is given by this right here. So we had one of these before. Find the number of seconds it will take to reach a maximum height. What is the maximum height? Okay. All right, so to find the maximum height. All right, the maximum height, here, let me draw a picture. An object is projected upward from level ground. So here's my ground. This thing is projected upward, and it goes up, and it comes back down, and look, it makes a parabola. And it's concave down, which means my A term is negative. See there? My A term is negative. It's concave down. Okay. Now this says the object will take how many seconds to reach the maximum height? All right, the maximum height right there, that's the vertex. That's the vertex. So all I need to do is find the vertex on this. So to do that, I first have to find the axis of symmetry, which I got to do x equals negative b over 2a. Okay, so on this one, negative b, my b is 32 over 2a, and my a is negative 16, and that's going to be negative 32 over negative 32, which is 1. All right, so this is going to, it will take 1 second to reach the maximum height. Okay, you can see the answer right there, 1 second. Now, the maximum height reached by the object is, all right, now that's the rest of the vertex. We found the x value of the vertex Now what's the y value? What's the y value of the vertex? So all I do is I take 1 and I put it in. So let's get my calculator here. I'm going to take 1 and put it in for t on this. I'm saying x, but it's actually t. I'm going to do negative 16, and then I got 1 squared, and then plus 32 times 1, and that's 16. So that means it reaches 16 feet. And you can see our answers right there. We're in good shape. So all we have to do is find the vertex for this. You have to know the axis of symmetry, which is negative b over 2a, and then you just plug that in. All right, and then the last problem here, number 17. All right, we've got this table over here. The table shows the percent of workers that stayed in their chosen field. The data are modeled by the following quadratic function. So here's the quadratic function that models this. Here's what you got to pay attention to. X equals 0 corresponds to 1990. So you can see here, this would be 0, 1990, that'd be 1. Oh, actually, that's 2. That's 92. That'd be 4. That'd be 6. That'd be 8. And that'd be 10. Okay? Predict the percent of workers that stay in their job in the year 2008. Now you can just write this up. 2002, 2004, 2006, 2008 means that this would be 12, 14, 16, that'd be 18. So x would be 18 here. Okay, so x equals 18 represents 2008. Okay, based on what the table is over here. So that means I would put 18 in the function here, and that would tell me my answer. All right, so let's get this thing out here. We'll type this in, so it's going to be a negative 0.06, and then in parentheses, I got 18 squared plus 0.46 times 18, and then plus 29.55. And I get 18.39. 18.39. That's the answer I get. All right, so 18.39%. Now look here, it says round to the nearest tenth. All right, now 10, remember 10 has 1 0, so this is 1 decimal place. So I just want this place. Does the 9 make the 3 go up or stay? Well, it goes up. That'd be 18.4. Okay. And there you have it. That is our quadratic functions and models. All right, so if you have any questions, give me a shout. I'll help you all I can, all right? Have a good rest of the day.